Chapter 1, Lesson 6. Multiplying and dividing rational numbers. Right, let's look at the first property in this lesson. Identity property of multiplication. What does identity mean? Who you are, yes. Yeah.
Like what the number is.
What the number is, identity, identical. So what is your goal? You want to end up with the same number. So if you start with a number n, how do you end up with the same number? You multiply by 1. So for every real number n times 1 equals n, and 1 times n also equals n. What is the multiplication property of 0? Luca?
Anything times 0.
Any number, any real number times 0 is 0. Alright? So n times 0 equals 0, and 0 times n also equals 0. Now this is a new property, multiplication property of -1. So according to this property, for every real number n times -1 is going to give you what? Can someone rephrase that? You're right. N times -1 is -n, but I want you to rephrase that -n and say it in a different way. Yes. Lulu? Kayla?
I think you could say any positive number times negative 1.
Now, does n have to be a positive number?
Yeah, because a positive.
For every real number.
Oh, real is a.
Now, when you say real number, it includes everything, right?
Yeah.
Positive numbers and negative numbers, rational and irrational.
But negative times negative would give you a positive, so that means it has to be. But then real, I don't know.
So how do you read that -n?
So positive n.
Now, it's not always positive. If it is positive n times -1 will give you -n. But if it is negative,
it has to be positive.
It would be positive n.
okay, so how do you read it, Annie?
The absolute value.
No.
That would be good.
N or its opposite.
What is it?
N or its opposite.
So how I would read this is n times -1 equals the opposite of n. Does it make sense?
Yeah.
N times -1 equals the opposite of n, because if n is positive, what will the final product be? -n. If n is negative, it will be positive. Alright? So what you see here this symbol is not always read as -n. Sometimes it's helpful to read it as the opposite of n. And -1 times n equals the opposite of n.
Should we add that to our poster?
The sheet.
No, you don't have to. No. Alright, so how do we read this? Read this as the
Is it hard to write on that?
it is hard to write. I'm just going to use. Alright, let me just write using the.
But if you put it on the actual board, it still picks it up, right?
Yes.
Yeah.
It's like with the computer. Is it gonna be easier when we get the special styles for that?
Hopefully. That's what they say. It's smoother and it's.
Wait, so if you're sick, you could teach us from
We could just watch
an iPad.
Yeah, I can just post it on YouTube, and whoever is subbing.
comments.
You
so we
could
don't have
do
to
the
read.
Yeah,
you could do all this while you're at home.
Yeah.
Okay.
And somebody commentates.
Let's just disable comments. talking about this if you love.
Okay, so you know this rule: when multiplying and dividing two numbers with like signs, the product, if you're multiplying, and the quotient, if you were dividing, is going to be positive. So positive times positive equals positive, negative times negative equals positive. And when you multiply and divide two numbers with unlike signs, the product or the quotient is going to be negative. So positive times negative equals negative, and negative times positive also equals negative. And we learned this last year. If you love to love, you love. If you love to hate, you hate. If you hate to love, you hate. And if you hate to hate, you love. Someone should make a rap song out of that. All right. So let's look at some examples. Negative 4 times positive 6.5, multiplying two numbers with different signs, the product is going to be negative. Mental math, Quincy? 26. 6 times 4 is 24. Half of 4 is 2. 24 plus 2 is negative 26. Big difference, right? Yeah. Okay. All right, this is also mental math. Negative 1.2 divided by negative 3.6. Luca?
Negative 0.4. No. It's going up because negative is fine.
What is negative divided by negative?
Positive.
Positive, right? Okay, look at the 1.2 and 3.6. Are the numbers telling you anything? Then we talked about numbers talking back to you in 6th grade. Are the numbers telling you anything? Yeah? Do you think they're compatible? Well?
Is it positive 3?
Is it positive 3?
Because there's 2 times 3 and then there's
Is it 3?
Oh, wait. Oh, yeah.
wait. Oh, 0.03?
Point.
0.03, yeah. Wait.
Okay, let's move the decimal point from where it is by multiplying both the numerator and denominator by 10. And if I do that, that's going to be 12, and that's going to be 36.
There's no easier.
And what is 12 over 36?
Negative, yeah.
1/3. Isn't it?
If it was 3.6.
So you can say positive 1/3 or positive 0.33333 repeating. Right, if x equals negative 3 and y equals 5, evaluate negative 3 xy. And I've given you a little hint there. What is the negative 3? Negative 3 is called the coefficient of the product of x and y. So what you're doing here is you're multiplying negative 3 times the value of x times the value of y. And can we plug in?
Yes, it is.
So it's going to be negative 3 times negative 3 times positive 5. Now let's figure out what the net value is going to be. Negative times negative is positive times positive is positive. Now multiply the constants. 3 times 3 is 9 times 5 is 45. So you have positive 45. How do you read that? Sam?
Negative x times y.
Negative x times y. Explain, break it down for me.
So it would be negative x and times y.
Wait, but
X is already negative.
x is already negative and it's a value. So if it's negative, does that mean that
Oh,
the
but
value
then-
is positive?
Oh, it's going off the top.
Let's go back to what we talked about earlier in the lesson.
That's a,
Is negative x the only way to read that?
The
Or is
opposite
there
of
another way
X.
to read it?
oh,
The
well.
opposite of X.
Annie, raise your hand, Will. Annie?
The opposite of negative
The R,
times.
just read the value, read the expression as it is. The opposite of x times y. Now, the moment you say that, it's as though you've received a revelation. Right? Everything falls into place. There's no more confusion. The fog is lifted. So you have the opposite of x times y, and you know that x is negative 3. So what is the opposite of negative 3? Positive 3 times positive 5 is going to be positive 15. You guys see that? So it's not, you can read it as the negative of a negative, but what would be more helpful is read it as the opposite of negative 3 times 5, which is positive 3 times positive 5. Okay, is there another way to look at this expression?
Oh,
Yeah,
the
Anton?
opposite of quantity x times y.
The opposite of the, say that again?
The opposite of quantity x times y.
Okay, now I'm going to write that out.
Because then you do x times y, then you find the opposite of it.
Opposite of,
I'm not sure whether I'm meant to use quantity, but I don't know how to include x in my
okay, quantity I'm just going to say xy.
Oh, you can do that. Opposite of product.
Are these two the same?
Yeah.
You get the same
Yeah.
Because negative 3
Well, that's
times 5 equals negative 15.
And then you
the
do that.
opposite, so it's positive 15.
I actually made a correction here, and for some reason it doesn't show. Now, what you're saying is the same as what I've written here, or what appears here.
In the work, it's
Correct. It's okay. I'm going to strike this out. So, how I should write this is the opposite.
Of x times y. Oh, of x.
like
And
the
then
opposite of
times
X.
y.
Okay, let me give me a second.
Or you could do like y times
1 second.
the opposite of x.
You can do the opposite of y times.
The product of the opposite of x and y. Do you see a difference between this and this?
Oh, yeah.
Yeah.
What I'm implying here, whether you go by Anton's version of what I written originally, what you're doing here is you're saying multiply x and y first and then find the opposite. Okay, but what we are actually saying here is this is the product of the opposite of x and y. So how do I actually write this as an expression?
Would it
Oh,
be-
you would put
oh,
parentheses.
parentheses.
There we go.
Around the x and y.
Make sense?
Yeah.
Yeah.
Okay, so this would be a translation of this. And this is the translation of that. Now, in this case, let's try if we get the same result. So we said the opposite of, what is x? Negative 3 times positive 5, which will be the opposite of negative 15, which will be positive 15. Now, we do end up with the same result. But is it always going to be the same?
Yeah. It would be.
Can you think of a counterexample? Any?
If you had a positive and a positive, so if it wasn't -3, it was positive.
If it was negative, if it was positive 3?
It would be negative either way. Because positive times positive is positive, then you change that into a negative.
Exactly. And this
Or
is
the
positive
other one
times
is negative times a positive, which is also negative.
But this here is the opposite of -15, so it's positive 15. That'd be the opposite of positive 15, so it's negative 15.
So then you do negative 15. I know, but let's say you have positive 5 times positive 5, right?
I have to capture this conversation. Good, keep talking.
I'm not like, but if you do positive 5 times positive 5, you get 25, right? And then you change that to a negative, you have negative 25.
Okay, let's try.
Original way, and it's negative 5 times positive 5, then you still negative 25.
So if x equals positive 3 and y equals positive 5, so if you do x, the opposite of x times y, and the opposite of product of x and y, this is going to be the opposite of
Yeah, it works.
3 and 5, which is 15, which is negative 15. Here you have the opposite of 15, which is also negative 15.
It works.
What if both were negatives?
It would be the same.
So the parentheses doesn't matter?
Yeah. I mean, you probably should solve it the way it's written, but
Oh,
I
no, it
don't
would
think it
make a
makes
difference.
no.
Would it?
Well, because then you have to multiply x times y first.
No, it makes a difference in the steps, but like he's
But the final answer is the same.
Final answer.
And really, it's
Yeah.
the same amount of work. It's
But
the
let's
same
say
amount.
Okay, let's try negative.
There's that problem we did.
If you x equals negative 3 and y equals negative 5, the opposite of negative 3 times negative 5, which is 3 times negative 5, which is negative 15, and you have, this is negative 3 times negative 5, which is negative 15 also. Interesting. Yep.